Graphing calculator problem number 3, unit 4 study guide. Another projectile motion problem. If s of t equals -1/2 gt squared plus v naught t plus s naught represents the position of an object thrown straight up from a initial height of 40 feet with an initial velocity of 64 seconds, and we know that g, the force of gravity, is 32 feet per second. We want to find when the object hits the ground. In order to do that, we need to substitute into this equation with our value for gravity, and with our v naught, our initial velocity, and with our s naught, our initial height. So we do that, and we get the function. We get the function s of t equals -16t squared plus 64t plus 40, and equivalently below it, how we're going to enter it into our calculator. So go ahead and enter that into your calculator and graph it. When you graph it, you should end up with something that looks like this. I started off with a zoom fit. It gave me a really zoomed out view of my graph, so then I adjusted my window and zoomed in on it so it was prettier. Now I just want to go ahead and calculate the zero of this function to figure out when it hits the ground, and I'll find that x equals 4.5495 yada yada yada. And then part B is asking me to find when the velocity of the object is -20 feet per second. Well, to do that, I'm going to go ahead and actually just use my power rule to calculate y prime equals, using my power rule, 2 times -16 is -32 x plus 64. I'm going to graph that. I'm also going to graph the line -20. So I'm going to have y2 and y3, and I graph that and find the intersection to be calculating that intersection point. Find y prime, which is the same as velocity with respect to time, and we want to find when that is -20. We find that happens when t equals 2.625 or x equals 2.625, however you want to think about it. And then question C asks us to find the velocity of the object when it is 10 feet above the ground. Well, first we got to figure out where is this object 10 feet above the ground, and by where I mean when, because our x values, we're talking about time. So at what x value is this object 10 feet above the ground? Well, graph the line y equals 10, calculate the intersection point between that and your original function y1 to find that the object is 10 feet above the ground at t equals. You'll notice that I just fancily wrote that the object is 10 feet above the ground at time t equals 4.424, which I rounded. So now I just got to find the velocity at time t equals 4.424, or honestly, better if you don't round it, but if you do, hopefully we'll be close. And we can do that because we already found our equation as -32x plus 64. We also already graphed it, so all we have to do is go to our graph for the x value, 4.424, and we find that the velocity is -77.56288 feet per second, and that is with the exact time value there. I went and stored it. Yay.